Hi, hello, good afternoon, good morning, depending on where you're joining from. And thanks, Irina, for inviting me and for hosting this cool event. And maybe big thanks for everybody who decided to sacrifice their lunch break to listen us. So my name is Nikita, and I'm a software solution architect. And for last few years, I'm working on some kind of intersection of system architecture, solution architecture, and AI, and really thinking what does it really mean to build scalable AI solutions, reliable AI solutions. And today I would like to talk about something that I believe is almost underestimated problem in AI development. And as you can guess, it's not about technical problems. So I would like to start with this phrase or with this thesis. This is the most important architecture decision you made last year. It was not a technical decision, and it was mainly how your teammates or your different teams talk to each other. So I would like you to maybe hold on this thought because everything I will be talking today about is built around this thesis, around this idea. So the problem is that architecture diagrams you have in your wiki pages, all these beautiful boxes, arrows, it's some kind of description of what you would like to build. It's a description of your, let's say, ideal system. But the system you actually have in production, it's a description on how your teams actually communicate. And the biggest issue is that these two things are almost never the same. So what we will talk today, so we will start with a Conway's law. It sounds like, let's say, dry computer science theory, but actually, from my perspective, it's one of the most practical and useful ideas in software design. Then we will look and check why AI systems make this problem even worse. So I will introduce some kind of fictional bank system which name is LARS, to make all things we are talking about a little bit concrete and to make it more illustrative. And then we will look how to find real boundaries. We will check maybe three patterns that make those boundaries manageable. We will also cover this inverse Conway maneuver. And at the end of our discussion, I will try to summarize all this stuff to give you something you can actually do on, so to say, Monday morning. It's not a strategy, it's some kind of specific actions you can form with your team. Okay, let's start with the Conway's law. It was created almost 60 years ago, but it's still applicable. It's still, let's say, from my perspective, it's the most uh, reliable and important and useful things which were even written about software design. And Conway's law tell us that organization which are designing software systems usually produce designs which usually copies the communicational structure of those organizations. And just an example, look at this slide. You can see three teams. For instance, Team A handles customer onboarding data, Team B runs a credit scoring model, and Team C deploys and monitors APIs. So we have three separate teams with different managers, with different sprint cadence, with different, I don't know, communication channels, Slack channels, and even they produce three separate components, modules with three separate interfaces. And the interesting illustration of Conway's law that these interfaces are fragile in a direct proportion to how badly those teams are communicate with each other. So these interfaces will inherit all this miscommunication with all these, let's say, bad practices, but let's say, even thickness of this communication, pain points of this communication between teams. So Conway's law, but so what? So architecture diagram, it's a mirror of our org chart. And the question is, do we design this mirror intentionally? So, because very often siloed teams produce monolithic components with hidden coupling, even coupling that nobody designed. This coupling just accumulates the boundaries between the teams. So we have unclear ownership for the services that nobody would like to change because nobody knows whom to call when it breaks. There is no shared language between teams, and lack of shared language surfaces as integration bugs at every boundary, but bugs not in from the logic perspective, but bugs in the assumptions. For instance, team A thought the specific field was a percentage, but team B on the same time thought that this field means ratio. Nobody write it down, and we have this conflict in assumption, this bug in assumption. And the problem is that Conway's law is showing us what is happening with our systems independently, whether we like it or not. And it's not a theory, it's to some extent it's real, maybe physics of your system, and you cannot just simply deny it, but you can only decide whether you're going to use it deliberately or not. So as we saw, Conway's law applies to all software systems, but AI systems have a specific property that makes team boundary problem even significantly worse. And yeah, let's check why it happens. So the problem with AI systems is it's not one team problem, as you see on this slide. We have at least 6 teams, 6 handoffs. For instance, data engineering team is working or responsible to work with raw data, ML engineering working with feature storage, data science is team responsible for building models, training. So at the end of the day, we have 6 teams. And if in regular software, if team A change some kind of API, team B will get team B, for instance, depend from team A, and in this case, team B will get a broken build. It will happen loudly, it will happen immediately, and finally, at the end of the day, we will fix this problem. But an AI system, it does not work like that. So, for instance, if schema change, this change might not be surfaced for a week. As a result, model will be retrained on a subtly wrong data. Even metrics will drop, but usually this will be treated as a noise. And 6 weeks later, we will have let's say a big amount of data which we need manually review. 6 weeks later, we will have, let's say, wrong prediction continued for this long period. And all this stuff, it's not a hypothetical. Every single of this problem happened in a production, in a bank system, in an insurance system, in a lending platform. But yeah, let's maybe give a name and give a face to this problem. As I promised, I will introduce our hypothetical bank system. It's named LARS. LARS stands for Loan Application Risk Scoring. It's a retail bank's credit decision engine, and every personal application sort out or gets one of three outcomes: approve, refer to human review, or declined. In total, this application works with 12,000 applications per day, with 87 milliseconds latency and around 2.4 million euros of average daily credit scoring. And in this case, if our model degrades, it will not just an inconvenience, it's about financial and regulatory risk. And in this system, 5 teams are involved. It's a data engineering team, it's a feature team, modeling, risk compliance, platform team, and we have 5 teams, but only one decision the system provides. And there are no written contracts between any of these teams. Let's maybe look at some kind of classical example of incident which can happen or which even happened in this system. So let's imagine week 1, we have a data engineering team which updates the bureau data schema. They implemented new field, something like DTO, ratio, V2, and something like this. But old field, which are deprecated, still stay in the scheme. Data engineering team even send a message through a Slack channel that schema was changed. But the problem is that feature team was not in this channel. Week 3, silence. Feature pipeline still reads the old feature. No contract checks. Training happens on outdated, on skewed data, and as a result, nobody knows. Week 7, model retrained on 6 weeks of skewed data. Metrics even dropped, but without cross-team context, it looks like some kind of variation and treated as a noise. Model deployed. Week 10, we faced a problem where the refer rate significantly increase. We have to manually review a lot of applications. We start investigation, and only during the 11th week we found the root cause. And at the end of the day, we have 10 weeks of wrong prediction as our credit score, and nobody was neglected. The failure was structural. There was no contract, there was no shared visibility, and there was no explicit ownership. But how do we find this problem in the future before it becomes an incident or some kind of real headache? So first of all, we need to start with boundaries. We need to define boundaries, so we need to review boundaries. And the idea is that boundaries are not on the org chart. Boundaries, they shows up as a friction. So friction in a discussion, friction in some kind of disagreement between teams, between, let's say, different silos, and trying to find the boundaries, we can use, let's say, 3 main, so to say, signals. Signal 1, it's a conversation. Signal 1 is about conversation becomes difficult when we have two teams and they need to have more than one thing to agree on a simple change. This is a boundary without a contract. And for instance, in the case of LARS, data engineering team and feature team, they don't have a standard protocol, no written agreement, and every change in the, let's say, in each schema was requires some kind of negotiation round. Signal tool says that changes travel silently. What does it mean? So when team makes a change and nobody tells to the downstream customer, because nobody knows who this customer is really is. As a case of, as an example of our LARS system, this implementation of new field deprecation was not announced, and there was even announced, but not to the customers, because there were no contracts. There were no contract with let's say with definition who should be notified, who is real user of this feature, the real user of this schema. And the third signal, or even a good exercise, is trying to answer the question who owns one or another artifact. If answering this question takes more than 30 seconds, it's again a place, or I don't know, topic to reflect about boundaries and the respective contract. For instance, you can even try to do this exercise with your team. You can pick one AI artifact. You can just try to ask who owns it. And if you will get answers, for instance, it depends, or I think it's probably, you have found a boundary that needs a contract. So the good news that these three signals does not require any kind of technical tools or architecture review. You can just run this diagnostic in your next retrospective or sprint review. Okay, once you know where to look, you need a lightweight way to make those boundaries visible. So at the end of the day, the simplest approach will be 30 minutes, sticky notes, a wall or virtual whiteboard. You can perform four main steps. So step one, put every team on a sticky note. Every team who touches the system or depends on its outputs, inputs. Step two, for each pair of team, you need to depict how often do they talk to each other, how well. For instance, thick line, or bold line, they communicate rather frequently with a high quality. Thin or dashed lines, they communicate rarely, or their communication are painful. The next step three, look for the thin lines. Every thin or missing line, it's a hidden architectural boundary. It's a place where you need a contract, not a contract, not a calendar invite, not a meeting. You need to think about contract. We will talk about contracts later, but it's a good place to the further reflection. And step four, for each thin line, name the artifact that crosses it. So it can be data file, a model version, a threshold. You should name it explicitly, and this is your contract candidate. And it's just a lightweight approach to make boundaries visible. If you would like to go, let's say, deeper, you definitely should look on Event Storming by Alberto Brandolini. And the map you will get as a result, the map you will draw is your real architecture. And if it surprised you, this is good. It was the main intent of this exercise. Okay, we have boundaries. Let's go next. Let's talk about patterns. And these patterns we will be talking about, they don't require platform rewriting or some kind of organizational changes. At the end of the day, there's some kind of contracts that help to make implicit explicit. And as we already discussed, as we already guessed, the first pattern, it's a data contract. Maybe just to give a definition, data contract, it's some kind of written version agreement between teams about the shape, semantic of data. Again, it's not a meeting, it's not some kind of event in a calendar, it's a artifact, not a Slack message. It's a document. This document ideally should be machine readable. Then later you can embed, you can use this document as a part of your CI/CD pipeline. Just to illustrate, look at the before panel. So we have a field name without explicit definition of its type. We don't know how often this field is updated. We don't even know the concrete customer, concrete, I don't know, downstream system which use this field. And as an opposite, we have a after panel with a data contract where we have a concrete field name with a type, with a range, with showing who is an owner of this field, with explicit showing whether this field is connected with some kind of deprecated fields, and even with direct mentioning of breaking changes notice. So if something will change or should change in this scheme, it means that according to this contract, downstream system should be notified in 90 days, not tomorrow, not on Monday morning. So you will have a time to be prepared for these changes. And at the end of the day, as I said, this data contract can be, and not can be, it should be embedded in your CI/CD pipeline, that it can validate this. And in case schema was changed or you have some kind of violation of schema, it can be and it should be checked before it reach production, before it reach training. And again, you don't need a specific tools to start with data contracts. It's just a YAML file or JSON file. It depends on, let's say, on your CI/CD pipeline tools. And this file definitely should be versioned, stored in a Git repository. And it's about discipline to writing down all your agreements, writing down the specification of interaction between components, between teams, and treating them as a binding. Okay, next idea that there should be no artifact without a clear owner. So here you can see an example of, again, of our LARS system. Each row it's a LARS artifact, but you can see that each column has each line has a column with a escalation path. This escalation path is maybe the most often ignored property in every system. Escalation path, it is answer to the question whom you should call, for instance, in the night, or when your pipeline, when your build is broken, when you have a problems with this concrete artifact. And also in this table you can see that we have an explicit mentioning of a review cadence, because ownership without review without reviewing schedule, it's again, it's a fiction. And the problem when data scientists train a model and platform deploys the old artifact was only possible because there was no ownership, there was no ownership records of model versions, there was nobody who can confirm that artifact in the registry matched the artifact which platform team deployed. Again, it's a 5-minute conversation. It's not a rocket science to create such kind of, let's say, registry of ownerships, of escalation paths, to define a review cadence. Small exercise, but big advantage, big use of such kind of structural approach. The third pattern about shared observability. So here's the main idea that teams should be able to see across boundaries without scheduling a meeting. So from this perspective, in your team, it should be 3 kinds of health metrics, health signals. It's a data health, model health, and business health. In the majority of cases, teams has only one of these health metrics. Some of teams has 2, but almost nobody connects all 3 into single view, which is accessible, or some kind of single dashboard which is accessible for every team. And again, in the case of our LARS system, it has an excellent system monitoring, but it had 0 cross-team dashboards showing the health metrics of the system. That's why in case when in our LARS system we faced a significant increase of refer recommendation from our system, nobody can notice it, and if we will have such kind of dashboard, this problem will be can be or could be easily found during the 4th week when we initially or firstly face this problem. Again, not rocket science. Seek to define 3 dimensions of your system health, create a shared dashboard, involve teams to work together on this, or maybe to collect requirements for these dashboards, to make the whole process visible across team boundaries. And it's not, again, a technical problem, it's a communicational problem and a problem of your teams. These 3 patterns, they are more tactical, they fix specific boundary problems, but I would like also to give you something which is more fundamental. It's a way of thinking about team design itself as in some kind of architectural act or architectural exercise. It's about so-called inverse Conway maneuver. The idea is you don't need to adapt your team to the system you have. You need to reshape your team to the system you would like to build. This term of inverse Conway maneuver was initially introduced in a book of Skeleton, in a book of team topologies. And this maneuver tells us that you need, in order to build, let's say, in order to build different architecture, we need to start with shaping our team first. We need to design a topology of our team in order to build desired and suitable architecture. And once you created a team topology, the architecture will follow. So according to the classical split introduced by Skeleton, it should be a stream-aligned team who owns the process end-to-end, platform team which provides infrastructure as a product, some kind of support, or in terms of team topology, enabling team, which embeds the expertise and when it's necessary, and all these complicated subsystems with complicated teams should be isolated in some kind of deep and specialized pipelines, workflows. And if we will apply this approach to our LARS system, instead of 5 siloed functional teams, we will have a stream-aligned team which owns the full loan decision flow, a platform team which provides an inference infrastructure as a product, enabling team that brings ML expertise when it's required, and all complicated subsystems, for instance, credit risk models, which teams own separately, they are isolated from operational pressure. So we have the same people, but different mandates, different boundaries, and as a result, different architecture. Again, just in a comparison, on the left side, you can see that architecture produced by the previous team, not structurized team from week 1 to week 11. We have 5 teams, we have no shared contracts, handoffs with informal agreements, incidents by surprise. And on the right side, we have 4 teams with explicit mandates, with a stream-aligned team, as I said, which owns the whole flow. And as a result, we have a data contracts, we have a clear ownership registers, we have a shared dashboards, which are not bolt-ons, and they are part of what it means to be a stream-aligned team, but stream-aligned team. And as I promised, maybe some kind of recommendations or summary for it's not even for agile coaches, it's for, let's say, for every team member who have an influence, who are responsible for this, let's say, for or can affect this team shaping. So you don't need to have an architecture authority to start with all this stuff we talked to today. You just need to have an influence, and I suppose you already have this influence since you are responsible for this team shaping. So the first thing you need to do, you need to map your team interfaces. For instance, in your next retrospective, try to draw who is talking to whom, about what, nodes are team, edges are communication, weights, how frequent and how, let's say, what's the real quality of this communication. And this map at the end of the day will produce your architecture. Step 2, name of one, let's say, start small, name one data handoff with a contract. For instance, you can pick the most painful team boundary, try to write one-page data contract with field names, with owners, with all these deprecation policies, with the explicit naming consumers. And having one contract, it's definitely better than having no contracts. And the third exercise, the third step you can do, you can start to ask questions about who is owning this artifact, for instance, for each AI artifact. And all these practices are also applicable not only for AI systems, but also for classical systems. And you can start to ask who owns this artifact. and you should get an answer, not an abstract answer, not like the data team or somebody. It's a concrete name, a team with mandate. If ownership is uncertain, it's likely the one of root causes of majority of your problems in your software, in your team communication. And the fourth uh, exercise, the fourth step, it's again, it's a step which is applicable for, let's say, for any kind of systems. You need to make invisible visible, implicit explicit. So you need to push for one shared dashboard across team boundaries, not for, let's say, some kind of governance because of governance, maintenance because of maintenance, but to make this transparency, to increase cross-team awareness, and yeah, to let's say maybe to share these meanings of your team terms between other teams, and to make, yeah, as I said, to make it transparent and to make it understandable. And maybe the main outcome, you need to design how data flows through your organization, not only through your system. And Conway's law does not care if you believe on it or not. As I said, it's a physics, it's a main law which regulates how your system, it's even social law, social technical law, but it mainly regulates how your architecture works under the hood, and it can help you to identify the bottlenecks and weakness in your communication patterns, in your technical patterns. And the good news, you can use this Conway law, you can use this, let's say, approaches we discussed today in a deliberate way, and you can shape your architecture in a way you would like to, or in a way you believe your system, or you know your system should be built for. Yeah, so it's all some kind of maybe recommendations for the further reading. And yeah, thanks a lot. It's all from my side.
Thank you very much for the insightful talk, Nikita.
Yep, always my pleasure.